Good day, everyone. So my report is all about chromatography. The term chromatography is derived from Greek word um, from Greek chroma meaning color and graphene meaning to write. So chromatography is a method of analysis and separation technique of organic and inorganic compound. It is used for large and small quantities. So it is used quantitatively and qualitatively and proved to be more effective from the other means of separation and identification. So the International Union for Pure and Applied Chemistry defined chromatography as a method used for separation of the components of the sample in which the components are distributed between two phases. One is stationary and other is mobile. Principles of chromatography. So chromatography is based on the principle where molecules in mixture applied into the surface or into the solid and fluid stationary phase or stable phase is separating from each other while moving with the aid of a mobile phase. The factors effective in this separation process include molecular characteristics related to the absorption or liquid-solid, partition, and affinity or differences among their molecular weights. Because of these differences, some components of the mixture stay longer in the stationary phase and they move slowly in the chromatography system, while others pass rapidly into the mobile phase and leave the system faster. Three components thus form the basis of the chromatography technique. First is stationary phase. This phase is always composed of a solid phase or a layer of a liquid absorbed on the surface solid support. Second is mobile phase. This phase is always composed of liquid or a gaseous component. And third is separated molecules. So the principles of chromatography, the physical method ng paghihiwalay ng namamahagi ng mga bahagi upang maghiwalay sa pagitan ng dalawang phases ay gumagalaw sa isang tiyak na direksyon. So ang mga sangkop ay pinaghihiwalay batay sa kanilang pagkaiba-iba sa pagitan ng dalawang phases. Ang mga sample ay dumaloy sa pamamagitan ng mobile liquid phase papunta o sa pamamagitan ng stable stationary phase. So separation of fractions of mixture based on their relative affinity towards the two phases during their travel. The fraction with greater affinity to stationary phase travels slower and shorter, while that with less affinity travels faster and longer. The separation is based on differential partitioning between the mobile and stationary phases. Functions. Chromatography is an important biophysical technique that enables the separation, identification, and purification of the components of a mixture for qualitative and quantitative analysis. So protein can be purified based on characteristics such as size and shape, total charge, hydrophobic groups present on the surface, and binding capacity with the stationary phase. The four separation techniques based on molecular characteristics and interaction. Type use mechanism of ion exchange, surface absorption, partition, and size exclusion. Other chromatography techniques are based on the stationary bed, including column, thin layer, and paper chromatography. So, column chromatography is one of the most common methods of protein purification. So there are four main types of chromatography. So first is gas chromatography. This method is one of the most common in the chromatography world, like all other forms of chromatography, it has mobile phase and stationary phase. In this case, the mobile phase is an inert gas, and the stationary phase is a column within the machine. So how does gas chromatography work? There's a cylinder outside the machine that contains the inert gas, usually helium or um, some other some some other form of unreactive gas. So also known as the carrier gas, the carrier gas is so named because it carries the sample in testing through the chromatography machine. From here, the lab technician insert the sample into the machine for testing. The sample will meet the carrier gas and immediately turn to gas form and enter the column. Once the sample enters the column stationary phase in gas form, the mixed sample will begin to separate into its components and record data using a detector. How to read the chromatogram of gas chromatography? Much information can be gained from the chromatogram on the health of gas chromatography or GCMS system, as well as the data required to perform qualitative or quantitative analysis. The x-axis is the retention time taken from the time the sample was injected into the GC or TO to the end of the GC run. Each analyte peak has a retention time measured from the apex of the peak, for example, TR. The y-axis the y-axis is the measured dispense of the analyte peak in the detector. The baseline shows the signal from the detector when no analyte is eluting from column or it is below the detection limit. So the baseline response is a mix of electrical noise, or usually low, and chemical noise, such as impurities in the carrier gas, column stationary phase bleed, and system contamination. Hence, if the baseline is higher than it is an indication of a problem or that maintenance is required. Various measurements that can be taken from the peak, such as width at the baseline, width at half height, total height, and area. So the letter 2 of proportional to the concentration. Um, However, it is the area that is used for quantitation, as it is less affected by band broadening. The measurement can be used to calculate the extent of band broadening, the spread of the analyte molecules on the column. So narrower, sharper peaks give better sensitivity, signal to noise ratio, and better resolution or peak separation. The peaks shown are Gaussian. However, peak tailing the right side of the peak is wider indicates activity or a dead volume in the system, whereas a peak fronting the left side of the peak is wider, indicates the column is overloaded. So accurate measurements are affected by the number of data points across a peaks, with um, an ideal number being 15 to 25. So so too few make the peak look like a child's. Join the dots drawing, affecting peak area resolution, and with GCMS deconvolution. So too many reduces the signal to noise, reducing sensitivity. For GCMS data, each data point is mass spectrum, the third dimension of data. So second is high performance liquid chromatography, while gas chromatography is arguably the most popular chromatography method. High performance liquid chromatography is a close second. This method is a favorite in many labs because of its efficiency using a liquid or solvent, mobile phase that pushes the sample through the machine using a high pressure pump. So additional, since the machines do most of the work, this method requires the least amount of training. So how does uh, HPLC work? So the HPLC machine include a solvent reservoir that contains the solvent, or usually HPLC, grade water with a small amount of acid, also known as the mobile phase. The solvent mixes with the liquid sample and carries it through the machine using a high pressure pump. The pump will bring the mixture to the column. The stationary phase that contains various pore sizes, and anything that passes through the pores remains the mobile phase. So, however, some compounds won't pass through the pores, causing separation and allowing lab technician to monitor the retention time. So, a detector will gather this data similarly to the gas chromatography to measure and analyze the molecules. The output or result of an HPLC can run is usually reviewed as chromatogram. This is horizontal series of peaks representing compounds eluted from the column with different RF values. So modern HPLC equipment is often to a diode, di, diode, diode array detector or DAD, allowing the user to look at the resulting chromatogram of separated compounds in wavelength from 190 to 900 namil, nam, nanometer nanometer. Um, so if the compounds under investigation are known, the user can choose to look at one or a few selected wavelengths. For instance, cocaine can be observed at 254 nanometer. So in this chromatogram shows the separation of compound from a chemical reaction, and chromatogram is viewed at 254 nanometer. So two main peaks occur at 8.20 and 9 minutes, representing two compounds with these retention times. So the number of observance unit or AU is shown on the y-axis while the time of the run is shown on the x-axis. So third is paper chromatography. So this is one of the less complex form of chromatography, but it remains one of the most popular. The mobile phase is a solvent or mixture of solvents, and the stationary is highly absorbent specialized paper. So how does paper chromatography work? Paper chromatography has a rather simple process. First, the lab technician will apply the sample to the paper, then dip an edge of the paper into a solvent such as water. From here, the solvent will travel up the paper and ultimately reach the sample, which separates the components of the sample, allowing the lab technician to measure and analyze accordingly. So in paper chromatography, the stationary phase is selected as a fine quality cellulosic paper. So different combination of organic and inorganic solvent are taken as the mobile phase. About 2 to 200 microliter of the sample solution is injected at the baseline of the paper, and it is allowed to air dry. The sample loaded paper is then carefully dipped into the mobile phase and not more than the height of 1 centimeter. After the mobile phase reaches near the edge of the paper, so the paper is taken out. The retention factor is calculated and the separated components are detected by different techniques. So the use of paper chromatography is performed to detect the purity of various pharmaceutical products. It can also be employed to detect contamination in various samples like food and beverages. And lastly is thin layer chromatography. So with this method, lab technician use a silica, gel, or alumina as its stationary phase and coat it onto a thin glass or plastic plate. The mobile phase is like high performance liquid chromatography in that it uses either a single solvent of a or a mixture of solvents. So how does a thin layer work? So the lab technician begins the process by preparing a fresh thin layer chromatography plate. Then the lab technician can begin placing a small amount of the sample onto a plate using a micropipette. This step is known as spotting the plate. Then they will insert the plate into a sealed jar that contains the solvent, and other time the spots will separate at different rates. This allows the lab technician to analyze the sample by measuring the distance traveled. So the thin layer chromatography, the stationary phase is uniformly applied on the solid support, glass, a thin plate, or aluminum foil, and dried. So the sample is injected as spots on the stationary phase about 1 centimeter above the edge of the plate. The sample loaded plate is then carefully dipped into the mobile phase, not more than the length of 1 centimeter. So after the mobile phase reaches near the edge of the plate is taken out. The retention factor is calculated as in paper chromatography and the separated components and detected by different techniques. An important property of any compound is its RF value or retention factor. In simple terms, this value is an indication of how far up a TLC plate a compound has wandered. A high RF value indicates that the compound has traveled far up the plate and is less polar, while a lower RF value indicates that the compound has not traveled far and is more polar. So this value is easily calculated by measuring the distance uh, the spot has wandered and dividing this by distance solvent has traveled. The RF value is dependent on both the compound and the solvent used for development. If we analyze two compounds and they give the same RF value with the same solvent system, the two compounds are most likely identical. So the apparatus for doing a TLC experiment is very simple. We need a developing chamber where the mobile phase is kept. The chamber should be sealed, and although there are special TLC chambers one can use, a beaker covered by a watch glass to create a seal um, surfaces. Often suffices. Suffices. Importance. So, chromatography is important by a physical technique that enables the separation, identification, and purification of components of a mixture for qualitative and quantitative analysis. So, chromatography in the pharmaceutical industries use chromatography technique for various purposes, such as for identifying and analyzing samples for presence of um, chemicals or trace elements, for preparing huge quantities of extremely pure materials, for separating chiral compounds, for detecting the purity of mixture and the unknown compounds present, and also in drug development. In the pharmaceutical industry, for identifying and for the quantification of drugs, the HPLC chromatography technique is considered to be the most crudel analytical method used. So this is used either in the drug's active pharmaceutical ingredients or its formulations during their discovery, development, and manufacturing process. A molecule with therapeutic value is beginning of drug discovery and development, and this can be done using the fast of ultra-fast HPLC chromatography technique for separation and during high um, throughout screening. So, in, in pharmacokinetics, biosay, bioassays, and metabolic studies, this um, chromatography technique is majorly used given its high sensitivity and selectivity. So chromatography method could be conveniently and successfully utilized for routine quality control analysis of drugs in the bulk and pharmaceutical dosage form, as these methods are accurate, precise, rapid, specific, and simple. They can be employed in drug discovery and drug development, drug impurities analysis, assay, and content uniformity, and method development and validation of drugs. So that's all. Thank you for listening.